Space, the final frontier. These are the voyages of
Chris Nye, the science guy. Chris Nye, the science guy.
Oh my.
Pluto had it coming from the beginning.
Don't cross the streams.
Chris Nye, the science guy.
Space is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. It's a great big, expanding void filled with stars and planets. Now for centuries, astronomers have tried to track the positions of celestial bodies in order to learn more about how the universe works. The branch of astronomy we're looking at today is called astrophysics, and it combines properties of physics and chemistry to find out what's in the universe and where it came from.
Come check out Chris Nye's newest album, The Sound of Science, featuring many songs such as Spaghettification, Pluto, Dead Star, Asteroid, and many, many more. Pre-order now for just $4.99.
And it feels like my feet are so far away. And it feels like my body is stretching in a million different ways.
Our universe began about 14.5 billion years ago, and everything had been condensed into a single point. But then a massive heat started to expand the universe, and it kept expanding and expanding, and that expansion is what we call the Big Bang. Now this Big Bang produced tons of hydrogen gas into the universe, and all that hydrogen began to form new elements, and eventually the whole universe was created from that one bang.
Before the Big Bang, a long time ago, everything was in a singularity. Very little is known about this point. Then, in the tiniest amount of time conceivable, the universe began expanding at a massive rate, and it was filled with plasma and quarks, the stuff that makes up protons and neutrons. Then, another split second later, those combined together to form protons, neutrons, and electrons, while expanding at just under the speed of light. By about 3 minutes after the Big Bang began, the universe had expanded massively and cooled to only about 100 million degrees Celsius. The subatomic particles arranged themselves into hydrogen and helium atoms and were floating about in a big superheated cloud. After 300,000 years, gravity pulls these basic elements together and starts the life cycle of stars. After a billion years, the universe as we see it begins to appear, with solar systems and planets dying and being remade in all the chaos that makes up our realm.
Hello, my name is Esteban Julio Ricardo Montoya de la Rosa Ramirez. This is my partner, Greg.
We've received news from a local police station that claims that they've received noise complaints from 3 delinquent teenagers in a local church parking lot trying to observe the Doppler effect. The Doppler effect is what happens when a mobile source is creating noise and observed from a stationary one. Now, this motion makes it so the wavelength of the sound is longer than normal and therefore is distorted.
breaking news.
This just in, the eggheads down in the lab have told me that the universe is expanding.
They say that this is because we can observe a shift towards the red end of the light spectrum from things that we observe in the universe. Because it comes from all directions, this means that they are getting further and further apart and accelerating at a faster rate. They say that this is directly related to the Doppler effect, as their wavelengths are just getting longer.
Let's get down to business to create the sun. Pluto sat alone on the outer rim, totally emotionless and labeled as a dwarf. The sun transmits a huge amount of energy into the earth. It warms the surface, it warms the oceans, it helps plants grow, and it even affects our weather. Without the sun in the sky, Earth as we know it wouldn't even be a possibility. The sun in our solar system is one of billions across the universe. Stars, like our sun, are huge gas balls of all sorts of different sizes where nuclear fusion occurs. This nuclear fusion puts off a ton of energy, and that energy becomes light. Now, stars don't last forever, of course. They go through a very long life cycle of billions and billions of years.
Stars are formed in clouds of gas and dust, known as nebulas. Nuclear reactions at the center of stars explode over and over again to provide energy for stars to make bigger elements and cause the stars to shine. The exact lifetime of a star depends mostly on its size. Very large, massive stars burn their fuel much faster than smaller stars, and may only last a few 100,000 years. Smaller stars, however, will last for several billion years because they burn their fuel at a much slower pace. Small stars, like the Sun, will undergo a relatively peaceful and beautiful death that sees them pass through a planetary nebula phase to become a white dwarf. This eventually cools down over time, leaving a brown dwarf. Massive stars, on the other hand, will experience a most energetic and violent end, which will see their remains scattered about the cosmos in an enormous explosion called a supernova. Once the dust clears, the only thing remaining will be a very dense star known as a neutron star, which spin at an incredibly fast rate. If the star which explodes happens to be especially large, it instead may form a black hole.
Now, black holes are hypercondensed pieces of mass with incredibly strong gravitational pulls. The gravitational pull eventually becomes so strong that not even light can escape it, and we call this point the event horizon. Because no light is escaping it, everything inside the event horizon appears to us as completely black. To demonstrate this, let's take a look at the fabric of space-time.
A wormhole is a theoretical passage through space-time that could create shortcuts for long journeys across the universe. Wormholes are predicted by the theory of general relativity. But be careful, wormholes bring with them the dangers of sudden collapse, high radiation, and dangerous contact with exotic matter. Mankind has theorized that using wormholes can be an effective way to bypass a lot of the struggles of space travel, such as massive distances and limited resources.
Hey now, you're a wormhole, you can travel through space. Hey now, you're a black hole, you make things go away. All these come from dead stars, no one's ever made it back alive. All these come from dead stars, no one's ever made it back alive.
Humans have been on the Earth for an incredibly long period of time, but with the threat of asteroids, the sun dying, and even man-made nuclear weaponry, eventually we'll have to leave. These challenges are known as great filters, and for our civilization to survive, we need to overcome them. Unfortunately for us, though, starships like this don't actually exist. We have no reliable way to traverse the universe.
The universe itself is on a completely different scale than we are. Its size makes it incredibly difficult for us to efficiently travel across it because of how proportionately slow we are. In addition to these vast sizes, the universe is constantly expanding, and it's expanding fast. For all we know, it could be expanding faster than the maximum speed of our spacecrafts, making it literally impossible to travel to other galaxies. So what's the point, you may ask? How can we possibly get anywhere? Well, there's a couple possible solutions to this proposed dilemma. Our first contender is to use wormholes to bend space-time and essentially get rid of the distance to wherever we're traveling to. This essentially gets rid of the problem of speed and vast areas to travel, as we can simply teleport to where we're trying to get to. Normally, it would take us a set amount of energy to get from point A to point B, like this. Wormholes allow us to instead jump between these points, which thusly keeps us from using almost all of the energy that it would have otherwise taken us to get there. Secondly, there's the possibility of using alternative fuels as they become available, specifically unlocking the capabilities of dark matter. Dark matter is an unknown substance that occurs everywhere in the universe but is both undetectable and thusly immeasurable. We know that this substance exists because mathematically it is impossible for the universe to be functioning as it is without extra mass being included into gravitational formulas and the like. If we figure out how this substance works, we may be unlocking a whole new method of opportunity in space travel. While these are all options for the future, we're still a long ways away from being able to apply them into actual space travel. Making significant discoveries and forming wormholes, experimenting with dark matter, and furthering the general design of making space travel possibility are all areas that need to be addressed by scientists and engineers. Every day could hold the next breakthrough in technology to get us to new galaxies and exploring the vast mystery that is space.
I've heard there was an asteroid that hit the Earth and the moon was formed, but you don't really care for astronomy, do you?
Three men are arguing about which of their countries is the best. The first man says, "My country is the best because we went to space first." The second man says, "My country is the best because we went to the moon first." The third man says, "My country is the best because we're going to the sun." "What?" exclaims the second. "How is that even possible?" The third proclaims, "This is possible because we'll go at night."